Welcome students. Let us see this question. This question says a black box with four terminals PQRS, as you can see PQ, R and S, contains ohmic resistors in an unknown arrangement. It is known that their resistance values are equal. Okay, and resistance measurement on the terminals lead to the following results. Between Q and S, there is no measurable resistance. Between P and Q, 5 ohms are measured, and the resistance between P and R is twice as high as that between P and Q. So we have to find which circuit does the black box contain. We have four options A, B, C, D. So see, this is the conceptual question. How to find the resistance or the equivalent resistance between any two terminals? To find the equivalent resistance between any two terminals, you have to apply a cell between those two terminals, and then you have to see your current distribution or the voltage distribution, and then you can decide whether it is in series or in parallel or in mixed up. So let us analyze the first option. We have zero resistance or no measurable resistance between Q and S. How we can verify? So if you want to find the resistance between Q and S, so you must apply a cell between Q and S. And please see the current distribution. So obviously there will be current flow between Q and S, and there is a resistance R between Q and S. Or current will not go in these resistors because there is no return path. So between Q and S, you have a measurable resistance, that is the R. Obviously, this option A will not be our answer. Let's see the next one. Between Q and S, we should have no resistance. So let us apply a cell between Q and S. Yes, you can see the current will flow from Q to S without any resistor in between Q and S. So the first option is satisfying here. Okay. The second one is saying between P and Q, 5 ohms are measured. So between P and Q, it means you should apply a cell between P and Q. And please see the current distribution. It will start flowing from here. It will go from this one, then this one, like this. Okay. So according to question, the total resistance, the equivalent resistance between P and Q should be 5 ohms. Okay. It may be that the combination of these two resistors, they are in the series. Suppose this is the R1, this is the R2. So it may be that R1 plus R2 is equals to 5 ohm. Maybe. Okay. Let's see the third option. The resistance between P and R. If you want to find the resistance between P and R, you should apply a cell between P and R. So the resistance between P and R is twice as high as that of between P and Q. So P and Q, we have the total resistance 5 ohm, means each resistor should be equals to 2.5 ohm. Why? Because it is given that all the resistance are of the equal values and they are in series. R1 plus R2 is equals to 5, both are equal. So we can say 2R is equals to 5, so R is equals to 2.5. Okay. It means according to this situation, each resistor has a value of 2.5 ohm. The third option is saying the resistance between P and R is twice as high as that of P and Q. So if we have applied a cell between P and R, please apply your current distribution. So current will flow from this to this. Okay. So here you can see both the resistors. See this was the R1 and suppose this is the R3. This R1 and R3 in series. So obviously again 2.5 plus 2.5, that is the 5. That is not correct because it should be twice. The resistance between P and R should be twice as high as between P and Q. So if the resistance between P and Q was 5, it should be 10. So this third option is not, the third condition is not satisfying here. So this B option should not our answer. Okay, let's check the third one. Again, the first option, the first condition. Between Q and S, there should be no measurable resistance. So between Q and S, if you apply the cell between Q and S, you can see the current will flow from Q and S, and you will have no any resistance, any measurable resistance between Q and S. Similarly, the second, between P and Q, 5 ohms are measured. So if you apply a cell between P and Q, current will start flowing like this. It will go here. So this was the R1. And according to question, this R1 should be equals to 5 ohm, right? Okay. The third one, the resistance between P and R is twice. So this is the P, this is R. So the resistance between P and R, please apply a cell between P and R. Current starts flowing like this. So current will flow these two resistors. This is the R1. Suppose this is the R2. So here in this case, the total resistance should be R1 plus R2. And since each resistor is of 5 ohm, because in the from the second condition, we get that the each resistance is of 5 ohm. So it should be 5 plus 5, that is the 10 ohm, which is twice of the previous case. So I think the C option is satisfying all the conditions. We may check for the D option as well. Okay, please see the D1. If you apply the cell between Q and S, see there is no measurable resistance between Q and S. So first condition is satisfying here. The second option, between P and Q. So if you apply a cell between P and Q, the current will start flowing through these two resistors. These two are in parallel. So this is the R, this is the R. Both have equal resistors. So in parallel, if you have parallel resistors in if you have equal resistors in parallel, so R equivalent should be R by 2, and this should be equals to 5. So according to this condition, R should be 10 ohm. The third one, the resistance between P and R. If you apply the cell between P and R, it will start flowing like this. It means there is no measurable resistance between P and R. So obviously the third condition will not satisfying here. So this should not be our answer. So the only answer is option C. I hope you have understood this question. If you have liked this discussion, please like this video, subscribe this channel and share to your friends. Thank you.